as you know, quartiles divide data into how many groups? Quartiles, 4 groups. So this word itself gives you the meaning, kind of. Quartiles divide data into 4 equal groups. So that is the basics. So whenever we are talking about quartiles, we are looking at a piece of data. So let us say this is the data for us. Let's say this is the data for us from here to there, okay? So data will have a lowest limit, which we call as the lowest datum. And the highest limit, which we'll call as the highest datum. And in between, we divide it into 4 equal parts. That means just the center. So that is called also the median. So it is also called the median, which you know, center value. We call this as second quartile, Q2. Now the data which is between Q2 to the lowest is again divided into 1/4, and we call this as the first quartile. Or Q1, and here is this center value is the third quartile. Or Q3. That is what we know. And the data which is between first and the third quartile is kind of the central data. So this data is kind of the central data around the median, right? So around the second quartile is known as interquartile range. Right, so this central value, which is concentrated around the median, is the interquartile range. Now the question is, if we are given, let's say, raw data, how do we find the first, second, and third quartile and the interquartile range? So let's take an example. So in the first example, I'll randomly write few numbers. Let's say the numbers are 2, 3, 1, 4, 6, 8, 9, 10, 12, 3, 4. So we have written 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. Okay. Now these 11 numbers are odd number of numbers. So in this case, what do we have? We have total of 11 numbers. So total numbers are 11. Is it okay? Now if I want to find the center value, that means position of Q2. Let's start with the center. How do I find it? Well, first step should be arrange them in a particular order, right? So first step should be always to arrange them in a particular order. So let's arrange in, let's say, ascending order. Okay, that means increasing order. So let's rewrite our numbers, arranging them in ascending order. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So we can begin with any number to start with. 2, let's write 2 here. Okay, 3 comes after 2, 1 comes before 2. Okay, 4 comes after, 6 comes after, 8 comes after 6, then 9 and 10 and 12, and then 3 comes here. Let's put 3 here, and then we have 4. Let's put 4 here. So we have arranged all the numbers now in increasing order. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have all 11 numbers in ascending order. Now, what is the position of the median, which is called the second quartile? To find the position, what we do here is, if the numbers are n, for example, then the position of second quartile, that is 50%, right? Should be, so we are finding Q2. So Q2 position is at 50% level. So what we do here is, if n is the total number, right? So we say, to find that position, we say n plus 1 times 50%, that means times 0.50 to find the position. This gives us the position. We are just finding the position, not the number, okay? So n in our case is 11, so we'll do 11 plus 1, which is 12 times 0.5. So let's calculate this position. So 12, half of 12 is 6. Half of 12 is 6, so sixth position. Is that okay? So let's circle the number at sixth position, which is, in our case, starting from left, 1, 2, 3, 4, 5, 6. So the number 4 here is the second quartile. You get the idea, right? So from here, we can say that Q2 is equal to the number 4. Do you get an idea, right? Now, how do we find the first quartile? To find the first quartile, it is always 25% mark. So this is at 25%, this is at 50%, and this one is at 75%. So 25% off, we could do this, 0.25 times, in this case n is 11, so we'll write 11 plus 1. Is it okay? So which is 1/4 of 12, 1/4 of 12, which is third position. So we can write this as, it is at third position. So what value is at third position? 1, 2, 3. So this number 3, do you see that? So we get Q1 as equals to 3. How about Q3? Q3 will be at 75th position, right? So 0.75 times 11 plus 1, which is 3/4 times 12, right? So 3 times 3, 9. So this is at 9th position. Do you understand? So at 9th position, we have the third quartile. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. The number 9 becomes Q3. Do you see that? So likewise, we can find first, second, third, fourth, first, second and third quartile from their position number. Now this was a simple case since we had odd numbers in our example. Now what happens if in our example 2, let's say this is example 1, we had odd numbers, and let's take even numbers now. Now for simplicity, I'll write down the numbers in increasing order. So let's say the numbers are 1, 2, 3, 3, 4, 5, 6, 6, 7, 8, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this time we have 12 numbers. So let's say the total number of numbers for us this time is 12. We need to find what is Q1, we need to find what is Q2, and we need to find what is Q3. Can you tell me how? So first, of course, we need to find their position. Find position. Since the numbers are already written in increasing order, we can find the position by using this number 12. So position for quartile number 1 is what? 12 plus 1? It is 12 plus 1 times 0.25. That is the position number, right? So 12 plus 1 is 13, right? So 13 times 0.25. That is to say that it is 1/4 of 13. Let me take the calculator now. and show you that's a decimal number, right? So it is 13 times 0.25, that gives us in decimals 3.25. Now 3.25 means 1, 2, 3. So somewhere here between these two threes. Do you see that? So 3.25 means a number in between these two. So the position is between, it is 3.25. That simply means that you're looking for a number between these two. So find average of these two. So Q1 will be average of these two. So it will be 3 plus 3 divided by 2, which is 3. So that is Q1. For Q2, let us first find the position. So since the total number is 12, so it will be 12 plus 1, which is 13 times 50%, right? So position is half of 13, right? So let's do it. So 13 divided by 2 is in decimals 6.5. 6.5 means that it is between 6th and 7th positions. 1, 2, 3, 4, 5, 6, and 7. So this number is between 6 and 7, right? So 1, 2, 3, 4, 5, 6. So it is between these two positions. Do you see that? And average of these two gives us Q2. So which is 5 plus 6 divided by 2, or 5.5. Similarly, to find the third quartile, first you find the position. So the position here will be 0.75 times 12 plus 1. So let's calculate this. 0.75 times 12 plus 1 is 13. And in decimals, this is 9.75. That means we are looking for a number whose position is between 9 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is between these two numbers. Between these two numbers, 7 plus 8, the average of these two gives us the answer, which is 7.5. Do you get an idea? So what we notice here is that to calculate the quartiles, we should know exactly how many numbers are there in our data. Position of these quartiles is Q1 25%, Q2 50%, Q3 is at 75%. So you need to arrange them in increasing or decreasing order. Once you do that, then Q1 will be at 25% of total number plus 1. That gives you exact position. If this position is a whole number, as is the case when we have odd number of data points, then you straight away get your answer. But if we have even number of data points, example here, second example, we had 12. In that case, to find the quartiles, we have to find average of the two adjacent numbers. You get the idea, right? So first find their position using the formula. Position is found using the formula n plus 1 times, depending on which quartile, right? If it is Q1, then it is 25%. If it is Q2, 50%. If it is Q3, 75%. If the number is in decimals, we are looking for averages between the two numbers. I hope this point is very clear, and that will help you to quickly find first the position and second the number associated with the quartile. I'm Anil Kumar, and I hope this concept helps you to calculate quartiles. Now once you calculate the quartiles, you can find interquartile range. Now what is interquartile range? Let me extend this. Interquartile range, so let's say IQR, is basically difference between third quartile and the first quartile. So find their difference. In the first example, the interquartile range will be 9 take away, let me circle the numbers, these two, right? So interquartile range for the first, let's say interquartile range in this case will be 9 take away 3, which is 6. And in the second example, the interquartile range will be, let me write down here, interquartile range will be equal to 7.5 take away 3. So it is 7.5 take away 3, which is equal to 3.5. So it is 3.5. Let me write down here 3.5, right? So that is how you could find the interquartile range. So the formula for interquartile range is the difference between the value of third quartile and first quartile, right? So that gives you the central value, right? So central half of the data is represented by interquartile range. So we can call this as central half of the data, right? So that is interquartile range. Now one quarter is towards the lowest quartile, the other quarter is towards the highest quartile between this. So that is how we can separate out the data and analyze it. I'm Anil Kumar, and I hope with this video is clear how to calculate first quartile, second quartile and third quartile and find the interquartile range when the data could be even or odd numbers. Thank you and all the best.